right. It's us. We're here.
Yeah, it's Tuesday.
Tuesday.
Yeah. Monday, Tuesday. Yo, we're Power and Speed. 908-751-0211. Like us on Facebook, Twitter, Instagram, whatever. You could make something up. Set up an account yourself.
If we had a little better social media presence, we'd probably be a little better.
Yeah,
off.
we should talk about that.
You know what I think the problem is? Neither one of us, we were just talking about this, neither one of us take this anywhere near seriously enough.
No, we don't. We don't. And people say we should. And Tad takes it serious.
Oh, yeah. Yeah, he's so serious he's not even here.
I was just going to say, what's up, Tad?
Yeah.
But
yeah, Tad is working in New York.
Oh, that's the story?
Outside.
He's outside New York?
From what I understand, setting railings.
Good
so
for
I'm
him.
Sure he's enjoying it out there.
So what's up? It's another week.
Another week. Well, I got to tell you, from the aspect of the guest goes, I mean, I know we had him on before, and he talked about products, his stuff.
Mm-hmm.
I'm looking forward to this because there's a lot of, black magic, surrounding turbos.
Yep.
There's a lot of misinformation.
A lot of secret squirrel.
Yep. This is kind of like talking to JC about torque converters.
Yep.
So I'd like to keep this one, pretty technical. And you said he is the guy for this.
He said he's the guy. I think he's the guy.
Okay.
So he's the guy.
All right. This is going to be good. But I got questions. I encourage anyone that's, as they're filtering into Mixler here, if you have questions about turbochargers in general, send them now. So we're not trying to look, and read your questions and come back and, whatever.
Yeah, because it's going to be tough. I was going to say without Tad here.
Really?
But who am I kidding? Yeah. All right. Sorry about that. I lost my mind.
Poor Tad.
Yeah. No, Tad's good. He's just Tad. Did he blow his shit up yet?
No, but I sent his injectors back to Paul.
Oh, good.
It was kind of funny. We talked about this before. I was going to send a note back with him, and I was going to write it. I was actually going to go to the Staples and get crayons and construction paper and write a note and draw like a picture of the injectors, write Tad with like the D backwards and everything, and send it back to him, asking him what he can do.
You should have done that.
I was gonna, but I think it would have delayed it a day. So
I think he would have enjoyed that. That's funny.
Yeah.
So that's a good move, sending him back, because I think Tad wanted to clean him with a pen cleaner. Or something.
Here's what happened. Tad's not here to defend himself, so
that's good.
It makes it easier to abuse him.
Yep.
He had something coming apart in his gas tank. I think it was a charcoal canister. Something was going on, and it was plugging up a sock and all kinds of stuff. And somehow or another, that was stressed to him by everybody, including the guy that was on the show that makes the injectors, Paul. Filters are important. You got to have a filter. He gets the car back. He's got just a sock on it.
Yep.
And I don't know why he drove it like that. I would have told him no, put the filter on, but it didn't get done. So then when it plugged the sock up, then you got to wonder how much got through and what and where.
Yeah.
And let's say you had an injector that its flow rate was down, 20% or something. Now you got one hole with a burned piston.
Yep.
I don't think he needs that.
No.
So he was going to spray him out or something. I was like, no, dude, they're going back to Paul. Just have him checked. It's cheap.
I don't even know how that, how could he think that could possibly work?
What do you mean?
Spraying him out. How could?
He was just going to spray in the ends of them and knock anything. In his mind, I guess that it was just stuff sitting in the screen of the injector, just sort of hanging out. There wasn't any kind of pressure or anything pushing shit through.
No, jamming it in there.
No.
It was stuff dying to get out.
And I'm not picking on him, but you
are kind of.
I am. He gets frustrated. You know what I mean? And he's like, fuck this. I didn't do this. I wanted a filter. And I was like, yeah, but that's cutting off your nose to spite your face. If you blow the fucking motor up and all you had to do was send the injectors back, take a few days. Your car sat there growing various fungi for years.
Yeah.
You could certainly wait to get the injectors clean.
And is there a filter on the car now?
Yes, there is.
Okay.
He put the filter on and then was cleaning the injectors after he put the filter on.
Okay.
So he was trying to, get back to zero. So I give him credit. He was trying to make sure that everything was okay.
Yep.
And I said, then why not go just that little bit further step? Just a little bit.
Good. You made him do it.
Yes, I did.
I could hear him.
I should have held his injectors here for a month. Oh, damn it, dude. I forgot to send him. I'm sorry.
I could hear him arguing with you. Don't care.
Yeah, exactly. Exactly. You don't understand.
Not my problem.
Yeah.
Dummy. That's all right. He's taking care of it, I guess.
Mm-hmm. So what about you? What's going on?
Work. We're getting heavy and not that you need to know this, but BMW is getting really big for me right now. I don't know why. It's like a rash of guys working on BMW and Mercedes stuff. I guess apparently they figured some tuning stuff out with them, and they make a lot of power, like with stock stuff.
A bunch of people, I've heard that from quite a few people.
Yep. Like the S-Series Benzes have been good for a while, but the M-Series BMWs apparently are pretty cool. 5, 6, 700 wheel with downpipes and,
Now, those things are a hot V configuration, correct?
Yeah. Yep.
Yeah. So, see, the only, like that kind of stuff, I enjoy thinking about the technology, and to be honest with you, it makes more sense. You think about it. Everything's kind of, right there. But, I mean, doesn't that make the aftermarket side of things really fucking tough?
Well, yeah, when that shit's one piece, like when they have one
piece.
I
mean, because now you're not, if you're going to do exhaust housing, what are you going to do? Cast a whole manifold? Or are you going to make some kind of modular deal where you've got a manifold and a housing?
I guess that's what they do. And I shouldn't speak out of turn because I'm not even sure of the configuration of the stuff I'm talking about, because it may not be the newest. It might be like 13, 14, 15 stuff that's getting worked on a lot now.
Mm-hmm.
It's out of warranty stuff, other than people that don't care about that. But so I don't know.
Well, if you're fucking with a Mercedes, it was, 150 out the door. Chances are pretty good that you don't care. You don't care a whole lot.
Yeah, I don't know where the Mercedes. I don't know if they're like the new Caddy where the turbos are built in to something. I don't know.
I'm sure the BMWs were.
Yeah, I think they were. I think you're right. But I mean, they put centers in them. I don't think they do anything to the exhaust side. Some guys might port them. I just don't know.
And they might just have a lot of headroom from the factory.
Yeah,
the way it is.
That's what it sounds like. I guess they're really, really turned down. But apparently the engines are very robust. Yeah,
but I mean, if you break those things, like, aren't parts like $1 zillion?
Yeah, it's crazy.
So I guess it is really for the people that don't give a fuck, because when you start fucking with stuff, you will break stuff.
Yeah.
I mean, it's going to happen.
Yeah. And they do break eventually. I mean, everybody goes to the end.
Well, I gotta bring up something kind of funny.
Wait, time out.
Yeah.
What were you doing before the show?
What do you mean?
I don't know. You turned a pre-show on for like 5 seconds.
It didn't matter. Alan's back from dinner.
Oh, you were trying.
He had a pre-recorder on, so I just turned it on, turned it off, just to irritate him.
Oh, nice. So you wouldn't have recorded?
No.
Beautiful. I like it.
Wait, what'd you say to me? You really are a dick.
Yeah.
And I said, oh yeah. Sorry, Fudd. I tried, but no, that's something. I am. God, I hate to say this, but it's true. I'm the old guy.
Me too.
I've seen a fair amount of stuff, and I've been around this a long time. And, I was around, in the very beginnings before there were things like, Dart heads and Buick heads for a Chevy. And I remember arguing with my old auto shop teacher who put Buick heads on a Chevy. You can't do that. I'm like, oh yeah, dope.
He didn't know.
No. But it used to be and I know we talked about this, but I am beyond shocked. I bought that little aluminum block motor for my truck.
The one you went and picked up.
So Jeff came up, he got his car back, he got a trans put on it, and it's, 1,000,000 times better. I took that thing apart. That thing had, I'd have to go back and look, but it was 300+ thousand miles on. I saw the truck it came out of. It had 300+ thousand on it. It was beat to hell.
Yep.
Do you know there's not even a top ring ridge? Nothing.
I believe it, man.
I mean, the bottom of the oil pan looks like a 300,000 mile deal, but the cylinders. I mean, if that was a Chevrolet, like, well, it is a Chevrolet, but I mean, like an old school, like say 1970s.
Oh, the pan would have been full.
Yeah, you wouldn't even be able, you probably couldn't even clean the thing at like 30, because I remember we used to get blocks, like you didn't want to go past 40.
Yeah.
And they wouldn't clean at 40. At 40, you'd have a lip, say, that thing's no good, throw it away.
And you couldn't get the pistons out the top.
No.
Yeah.
These things fell out.
I know. It's just better shit, man. Everything runs cleaner, better. Everything's tighter. Cylinder walls, I guess, are harder.
Is it oil? Is it a combination of everything?
I don't know. I don't know how oil could help the top ring life and how it doesn't burn. I mean, oil burns, if you light it.
Well, I can tell you this as far as worn out goes. Pistons, just covered with blow-by.
Yep.
So it was worn out for sure.
Well,
but I think the rings were just worn out. But yeah, there's no lip. I even took a little piece of, Scotch-Brite and went around the top of the board just to look. There's nothing. Nothing in major or minor. Nothing.
And you did say the bearings looked really good.
Fine. And they were stuck in the rods. They still had retention. They didn't just fall out.
Yeah.
But funny enough, this is the second one I've taken apart that's like this. The cam bearings are beat up.
Yeah, I know. Somebody talked about that many shows ago, that they beat up cam bearings for some reason. I thought, we talked about this the other day. You were telling me that, and I thought somebody had brought that up, but I don't know why. I know I'm reading I'm trying to pay attention and also see if there's questions coming in. But
yeah, and like guy Cameron said, lack of overfueling. Yeah, I mean, probably a bunch of it is the engine just runs more efficiently.
Yeah.
Clearly, you're not getting, the kind of mileage we get with a 1970s, conventional V8.
Yeah, and Dale said low tension, and that's true too.
I think it's all part of it, but I mean,
it's all been figured out over time.
Just amazing.
Yep.
Just amazing. I mean, because you just wouldn't even think about something with 300 on it. That's why I was asking you about the valves for the heads. I was like, dude, I want a good valve because I don't want to hurt it, by accident, like where you could have put something better. If you're going to buy something, put something better in.
Yep.
And I was concerned, like if you get some of the better valves, like, you get the titanium stuff, the beryllium stuff, they'll wear more. They're not as friendly. So I just wanted to make sure that the stainless materials were all good. And you said, oh yeah, they'll go, for millions of miles.
Yep.
No problem. But that thing, I was impressed. I really was impressed.
Well, like we've said a million times, the engineers at the OEs are not a bunch of dummies.
No.
We used to think they were, back in the 80s and 90s when we could do everything better.
Mm-hmm.
Better cam, better piston, better everything. But
like the guy going to get the dual point, Excel distributor, and you look at the thing on the distributor machine and shit is scattered everywhere.
Place,
Lights are everywhere. Like things aren't even remotely 90 degrees. Oh my God, that was always funny.
Yep. God, remember them days?
Yeah.
Distributor machines.
I know.
Holy God.
I remember spinning that thing up. I remember when I first learned to do it and getting the curves right, for what you were trying to get them to do and everything. And now it's do it a keyboard.
Yeah. In 1 second.
Half the people today be like, what's a distributor?
Yeah. They are, actually. They don't know.
Yeah, so that little guy's all apart. So that's good. That's that will be a spare because I'm relatively sure the other thing's going to blow up. I got to talk to Allison. She's not on there, is she?
I didn't see her yet.
We should make her call in and give a status update and figure out when the dyno's going to be finished.
Yeah, I got a guy that is willing to rent it too.
Rent it? Like I don't have to do anything?
Nothing.
All right.
Just you have to hold your hand.
Do I have to be here?
Well,
do I have to talk to him?
That's up to you. Probably not, but all you have to do is hold your hand out and take money.
That always works for me.
Yeah, I figured.
All right, now I know there's a bunch more people in here than there were in the beginning. Tonight we're going to be talking to Force Performance.
Robert Young.
And he's a very good technical turbo guy. So if you guys have questions, put them in Mixler. You might have put them on Facebook. I'd never know if you did. I don't know if Tom's looked.
That's funny.
Yeah. So, I mean, probably in Mixler would be the best place. And maybe I'll try to poke it on Facebook while the guy's on the phone. Let Tom keep talking.
Yeah.
But if there's any questions about why things ball bearing versus journal, we can bring that up again. We talked about that with Bill Devine.
Yep.
But that was pretty good.
Well, we got to bring it up because
volute, yes, the legendary word. But I want to point out to all you fuckers, I had the name right.
Yeah.
And you guys are making fun of me. That's the name of it. What do you want me to say?
Nobody ever said you were wrong. It's just a funny word.
Fuck you guys.
And we have to ask the ball bearing versus journal because it was Rich Guido, and he, as we know, he could beat all of us up.
Yes. Ninja.
Yeah.
He's allowed to pick on me about volute.
Yeah.
Let's see. What else we got? Oilless Turbos. I don't know how many people know about that. I mean, that was something. Who made those things? Was it Aeromotive that made them for Harleys and motorcycles? I think.
I have no idea.
If Danny Sylvester was still alive, he used to be into that because they were pretty easy. I mean, there's no plumbing. It was pretty easy.
Yeah, but I don't know how. I mean, could they really last?
They did on motorcycles, but they don't typically see the kind of mileage that a car would say.
I don't know.
Probably not for racing, but yeah, Harley kits. Yeah. All right. I'll ask.
Yeah, Robert said Harley kits.
But we're gonna. Oh, Comp makes oilless, really?
Oh, Aerodyne.
Yeah, Aerodyne. That's who it was.
Yeah, Comp makes oilless. Yeah, well, who buys Comp?
Hey,
turbo?
hey!
Sorry,
don't pick. You never know. Like Edelbrock, they won't even talk to us now after Dave ran his grill. And
remember that? They will. They know Dave's a schmuck.
So yeah, if there's questions you can come across, put across, it would be good. Compound turbo sizing, I don't know. That probably gets pretty deep, but we can certainly talk about that, and it's interesting, especially from the street car perspective.
He might know the like kind of the whys and the what ifs type thing.
Look, the things that I've got: AR trim, AR versus housing and housing type.
Oh, PJ's got a comp turbo.
Okay.
Oops. He called me a dick.
Good.
And he's right.
Back pressure statistics, energy. Is there an energy calculation, to figure out turbine sizing? There's a lot of things that like were rolling around in my head, like just trying to understand.
I wonder if Robert's listening and he's wondering if he should call in now.
Might be like, yeah, well, those guys are idiots.
That could very well be. I think he might have known that already. Hey PJ, since you're typing away over there, is your
good
turbo
question?
Is it oilless?
Divided versus not divided? Yeah, it's a good.
Actually, Robert brought that up to me when we were talking.
Don't ruin it.
We were talking.
All right,
you hoser.
Divided.
We got to find our sound effects again. We got nothing.
Yeah, the asshole's gone. Where the white women at? It's got everything. Everything from Blazing Saddles. All gone.
Don't mess up my show, you hoser. Come on, man. That was one of my favorites.
I'll find all that shit. This might be Robert, but I don't have the phone system open.
Probably should, no?
Probably.
Since the whole plan is to take a call. You got to give us
Nothing would be worse than going through all this and finding out it's Rich Mogul. Nope, it's not.
Rich feels good now. Hey, Robert, you're on the air, man. Thanks for coming on. What's up? What's happening?
Happy Tuesday, everybody.
Oh, yeah. It's always fun when it's Tuesday, isn't it?
Mm-hmm.
Well, we've been following along, and, man, some great questions so far. I'm excited to jump into this.
Okay. Well, start with how have you been? How's everything out there?
Oh, man, things have been going great. This past year, we moved buildings, we moved locations. We moved another 30 miles or so north from where we were, just north of Dallas, up to Van Alstyne. Got a much larger building, and we're still in the process of building into it and operating out of it simultaneously. So it's been an exciting year so far. I really can't complain a bit. It's been awesome.
How close are you to Tony?
We get farther and farther away all the time. He keeps moving out his direction east of town, and I keep moving out my direction north of town. So an hour or so.
That's not bad. I mean, I know he uses a lot of your stuff, and with good reason. And
I love working with Tony.
Yeah, he's a good dude.
We should probably recap for people that don't know who Robert is.
Who they shouldn't even be listening if they don't know who he is.
I know.
Hang up if you don't know who this guy is.
We have a bunch of slackers. But I mean, Force Performance, I mean, you can certainly tell us how you got into this and where you came from. We'll just hit that real quick because I know we did this before.
Well, you bet. Started during turbos in the late 90s, basically Mitsubishi hybrids for DSM applications, and just kind of kept morphing and evolving with that up till today. So mainly a background in custom Mitsubishi turbochargers, custom Subaru turbochargers, but now that's panned into GTR and universal fit performance stuff that gets used on just so many different things. The half mile racing and the mile racing now is really where a lot of the action is, and I really enjoy participating in those kind of events. The cars are just getting amazing. It used to be that we had a 500 horsepower car, and that was a lot of power, but I mean, these guys are having 1,500 and 2,000 and 2,500 horsepower cars now. It's just amazing.
Yeah, we talk about this. I'm 50, and I like my first, street car made like a little over 400 with a hydraulic cam, and I was thrilled. And then went to a flat tap it, and made 500. Like, I'm a bad motherfucker.
Yeah,
and now somebody laugh at you.
It's a joke. It really is.
Mm-hmm.
Hey, Robert, one thing before we get technical. I just saw, you said DSM, and that's where you got your start. And I just saw the picture of you and Marco from back in the day. It was actually a pretty good picture.
That was a great picture, and that was a great shootout. And I tell you, Marco has been a really important part of this community. A lot of people, deserve mentioning if you're going to go down memory lane there, but Marco has really been a big part of it from the beginning, and I always love catching up with him whenever I get a chance.
Yeah, me too. He's a neat guy and very smart, and you just can't be really out with him anywhere.
Yeah, he's got a lot of really cool stuff going on these days. I mean, he is all over the place doing ECU work. He's either in the Middle East or in Europe. He's always off doing some really fun stuff. Man,
I think Panama is his place now. He loves being to Panama.
Yeah.
Yep.
Mm-hmm, mm-hmm.
But anyway, all right. Well, we're going to get to the questions because there's a lot we want to get to, and
I don't even know where to start because there's so many subjects that like all tie into, that like it's all about a turbocharger. It's like kind of asking a guy like, wait, let's talk about building motors. Where do you want to start? They all matter.
All right, let's start simple. Guido asked before. I want to get him over with so he doesn't beat anybody up.
All right.
We had a listener ask journal bearing versus ball bearing.
Yeah.
Advantages, disadvantages for longevity, power. I mean, is there a general rule of thumb? Go ahead, fire.
Oh, yeah. You bet there is. This is a great topic. The basics of journal bearing versus ball bearing, from my perspective, from the sort of turbochargers that I work with, really comes down to, can the turbo survive abuse well? Journal bearing turbochargers are less able to deal with abuse than ball bearing turbochargers are. Here's why. It's a really great analogy that I like to use comparing ball bearing turbochargers and journal bearing turbochargers. You remember the air hockey game you used to play when you were a kid?
Mm-hmm.
Yep.
Okay. When you turn that little air pump on, that puck, it slides right across the table real fast. No friction. It's not touching the table. But if you turn the air pump off, and the puck slides across the top of the table, it doesn't get very far very quickly. It's scraping along the top of the table. The journal bearing really depends on that. That's the principle that makes the journal bearing turbo work. Okay. Yep. And in the journal bearing turbocharger, the hockey puck and the table is the shaft and the bearing, or the bearing and the bearing housing, or the thrust collar and the thrust bearing. Those two pieces move at a really high surface velocity relative to each other, and they're never supposed to touch each other. They're always supposed to be supported by this hydraulic pressure that is built up in the space between the shaft and the bearing, and between the bearing and the housing, and between the thrust collar and the thrust bearing. There's supposed to be a hydraulic pressure there that keeps those pieces floating and not touching each other. But unfortunately, what happens a lot of times with what we do with our cars is we want to launch them on a two-step at 6,500 RPM and 30 pounds boost, and we're going to pull a 1-2-60 foot time. And what happens is you got just as much or more gravity pointing backwards as you do towards the ground. All the oil goes to the backside of the motor, and you suck some air, you suck some foam with the oil pickup, and the turbocharger, which is at 30 pounds of boost on a two-step at 6,000 RPM, is a very high shaft speed, very high surface velocity on the journal bearings. And if you pump foam to them instead of good oil, or heaven forbid you pump air to them instead of even foam, those pieces in that turbocharger are now going to touch. Well, anything that's touching and it has a high surface velocity relative to the other component that's involved in the touching is going to develop a lot of friction really quickly. And you will only do this once or twice before you have a bearing problem with the turbocharger.
Okay, so abuse, just to be clear, when you were saying abuse, it didn't mean you were doing something wrong. You're just talking about the rigors of use for, say, hard launches and drag racing. Yeah.
Yeah, well, yeah, I would consider not having oil pressure for the turbo being abusive. I guess is the point I was making.
Yep.
So now, if you're going to have a ball bearing turbocharger on the car, everything's the same except we no longer have those same surface velocity things, and we no longer have the hockey puck analogy. Now we just have a ball rolling across the top of the hockey table. It doesn't matter if the air is on or not. Okay, the ball rolls across the top of the hockey table just the same way in either case. So when you launch the car and you have momentary loss of oil pressure when you launch the car, the ball bearings in the turbocharger, they don't care. There's already some oil there, and they're happy.
Okay.
So no damage.
That makes sense.
And this was a nice way to start the conversation because now it gave me three things.
Turbocharger can't tolerate that.
Got it.
Okay.
All right. Now this is something that this came from me, but I know people had asked similar stuff. Oil flow restrictors, pressure. Is there any way to figure out what the turbo does or does not need, or are there, general guidelines?
Well, I think generally speaking, you're going to want to ask the people that you bought the turbo from what they recommend. But as far as journal bearings and ball bearings go, there's some really rock solid guidelines to go by. Journal bearing turbochargers in like the T4, Hulsit, HX40 size, those size turbochargers, they need a dash 4 line with about 50 pounds of oil pressure in it in order for them to operate at full power. At idle, they can get by with about 5 or 10 pounds of oil pressure going to the turbocharger, but at full power, they need about 50 pounds of oil pressure through a dash 4 line.
Okay, and that's a journal bearing, unrestricted.
Correct. Now, you would typically run that unrestricted in a dash 4 line, and that's what you'd be shooting for, is about 50 psi delivered to the turbo.
Okay.
You wouldn't normally use an oil restrictor for that unless you had an engine that you just knew was operating at like 120 psi or something, and the only place you could take the oil off the motor was really high like that at 120 psi.
Mm-hmm.
You would need to cut that down some. But on most engines, you can find a different place on the engine, like off the cylinder head or someplace after many of the bearings in the engine, and the pressure will be considerably lower at full speed and use that instead. Or you could restrict it if you're limited to only having the high pressure port to tap off of for supply of oil.
Okay. And there's a guy, Mr. Lee, just asked about an AccuSump for turbos.
Yeah.
I think they kind of help everything, don't they? I mean,
it's a great idea having an accumulator. The AccuSump and AccuSump, I'm not exactly sure. I don't have a lot of familiarity with that product, but accumulators that store oil, and when there's a absence of oil pressure in the galleys, they will put the oil back in. That's a great idea, but the turbocharger bearings, again, they're very tiny, very high surface velocities, and really like, half a second worth of crappy oil pressure and crappy oil delivery to them can cause them to be damaged.
So it's really too late. It's too late already.
It would almost be too late, in my opinion. Yeah. Now, larger bearings that have more surface area and have lower surface speeds, like rod bearings or main bearings, it could probably really help with that. But my experience is with turbochargers, that system's not going to react fast enough it's going to come in like a fireman after the fire's already on. And
that makes sense, actually.
Yeah.
That makes perfect sense. So I guess essentially what you're saying is a journal bearing turbo, they make good power. There's nothing wrong with them, but in
cost affordability.
Yep. But in that in a drag racing application where you got high G-force and I guess once you get into the higher levels, you're taking risk.
You're taking some risk, and it really happens depending on traction. You don't see it with guys that go do highway pulls. You don't see it with the roll race crowd, because they might pull half a G forward acceleration compared to a rotary Corolla, that launches and doing a wheelie. You have way more chance of losing oil pressure on something like that than you do on something that is just slowly accelerating highway style. The airport racing is a good example of that. Yeah. You can get by with a lot more horsepower airport racing than you can drag racing.
I guess the bigger and the heavier the wheel, which is what you're making big power with, also affects it.
Yeah, the loads of the turbocharger definitely go up when you put larger wheels in them, and then or you're talking about the wheel, the tires and wheel package for traction. That's just going to result in you being able to create more acceleration G-forces more instantaneously.
I'm at the turbo wheels being bigger.
Yeah, turbo wheels. Yeah. Well, normally the bearings scale with the wheels, so there's some weird excuses for when they don't. When you're really trying to stretch airflow out of a really small frame size, and you might be overpowering the bearings a little bit. Might be a little more sensitive to that for sure. But generally speaking, when you go up from a T4 turbocharger to like a journal bearing GT42 turbocharger or a journal bearing GT55 Garrett turbocharger or S400 or something like that, the bearings in those are enormous. Those turbos aren't designed for low drag or anything like that. Those turbos are designed for their strength, so it can be a little bit less of an issue there. But really, you can get around this problem by dry sump oil systems. That separate the foam out of the oil. Baffles in your pan, modifying the pickup in your pan, doing things like that with your motor so that you don't suck air. There's a lot of guys that run general bearing turbochargers and don't have problems because they solve their oil pressure problems.
Yep. That makes perfect sense as well.
Does make perfect sense.
So you just got to be aware of where you're going with your systems. It sounds like to me.
Exactly. Well, it kind of goes back to, it's more about just this one component. You got to have the whole package lined out. All the parts have to work together at the end of the day. So, whereas on the general bearings turbocharger, on the ball bearing turbocharger, those things can operate with intermittent oil supply because you have such a small restrictor on those, like the Zona rotor turbochargers currently, they run a 20 thousandths restrictor. So, and you could send as little as 10 psi of oil pressure to those, 10 psi to the restrictor. So it's really getting just a minimal amount of oil inside of it for the balls to keep them lubricated. And that's really all it takes. With the materials that, the material selection of those turbochargers is superb, and they really can get by with very little oil. Matter of fact, we've got a story about a flat six application where we put 2 Zona rotor turbochargers on it, and one of the oil fittings didn't have the restrictor drilled through it all the way. So the left side turbo had a 20 thou restrictor on it. The right side turbocharger didn't have the 20 thou hole drilled all the way through the oil jet in the oil lines. They didn't find out about it for 3 weeks. They put the car together. They mapped the ECU. The car got delivered to the customer. The customer drove it around for a couple of days, took it to road course, did a couple of 20-minute sessions on Saturday, and broke the turbo on Sunday when he went back.
Wow.
It never got any oil. All it ever had in it was the assembly lube.
Is that ceramic ball bearing?
Those are ceramic ball bearings. Yeah. Very, and the races are very, very high strength steel races.
Yeah. Yep.
I was just going to ask what kind of role the oil plays in cooling of the ball bearings, but I guess
very little. And in the case of the Zona rotors, very little, because we don't send very much oil into the turbocharger. To be honest with you, and a lot of customers really like that because one of the biggest complaints that people have with expensive turbochargers is that they might smoke. Now it's a complaint on an expensive turbocharger because you spent a lot of money, right? Okay. Yeah. It's the same complaint you have on an inexpensive turbocharger, but when you spend a lot of money, you're even more upset about it. Normally this happens because the system is they're not playing well with others sort of thing going on. You have a really low mounted turbocharger. You're sending way too much oil to the turbocharger. You've got a loop or a P-trap looking thing in your oil drain line that causes the oil not to be able to get away from the turbocharger. Those sorts of things happen all the time when people, not motor companies build cars, but when people individually build cars, sometimes, mistakes are made or things are less than optimal just because they have to be less than optimal. If you got a land speed streamliner motorcycle, you have only this space to put the turbo. There's not another place to put the turbocharger. That's the only place to put the turbocharger, and it just so happens to be below the oil level. You're just going to have to find a way around it. Applications like that, you typically put a sump collection under the turbocharger and use an electric pump to suck the oil
out. Back up. Yep.
And pump it back up to the motor, right?
Yeah, that's actually Nathan had asked
about return size.
About return size.
Yep.
Like I would imagine that the return size is just kind of as big as comfortable, right? Bigger is better.
When it comes to returns, 1/2 inch diameter is what I recommend for just about everything. 1,000 horsepower and down is about what I recommend, a 1/2 inch drain line.
Wow.
Okay.
1/2 inch ID.
Yeah. Yep.
And you get into trouble sometimes. You run that through a bunch of 45-degree fittings so that it snakes around that pressure sensor that's mounted on the pan where you wished it wasn't mounted.
Yep.
And you end up with this conflagrated fitting fiasco going on there. Not all those fittings. It might be a -12 fitting, or a -16 fitting, but it may have a lot of sharp edges and reduced cross-sectional areas in different places, and that really complicates things. The oil that comes out of the turbocharger is like a Slurpee. I've got a clear drain tube on my turbo test stand, and you wash the turbo running on the test stand. The oil that shoots down the drain tube is not liquid. It's not brown looking liquid oil. It's foamy, frothy oil. So it needs a cross sectional area to flow through, or else it's not going to. It's just going to stack up.
Okay.
Just a quick question. What about any oil additives that help or hurt zinc in the oil?
Well, specifically with journal bearing turbochargers, yes. Okay, because ZDDP, zinc, phosphate, they become really important in that momentary, instantaneous absence of oil pressure, and those pieces do touch down and hit each other, and there's not enough oil film between them. The zinc is the only thing that's left. So yes, it is a great last ditch protection measure for your high-speed moving parts that need lubricant, like your journal bearing turbochargers, thrust bearing, your journal bearing turbochargers, usually your weak spot.
Okay,
makes sense.
Ball bearing turbochargers, again, less of an issue. You can run just regular, emissions grade Mobil 1 on most ball bearing turbochargers, and you don't have any problems.
Okay,
Roger.
All right, let's get into housings.
Go,
because that's something. So, all right. I think anybody that's looked at, say, the Garrett webpage, they can certainly figure out what AR means. And if you want to get into it and explain it, you certainly could. But what I'm curious about here is this AR relationship. When you go from, say, a V-band housing to a T3 housing to a T4 housing, is the relationship like is a 0.82 comparable to a T4 and a 0.82? Or
that's a great question too.
Is that because the overall housing changes, so then the math changes to give you, because AR is like a ratio. So it's not really a measurement, it's a ratio.
Well, but it's not a dimensionless ratio, okay?
True.
That's where the monkey works come in, okay? Because it's an area divided by a length. So, if it's 0.81, it's 0.A1 something length measurements. Follow what I'm saying? Because area divided by radius, area is going to be like, say, centimeters squared, and radius is going to be centimeters. So you divide centimeters squared by a centimeter, you're left with a centimeter at the end. So it's 0.81 centimeter so what size is this housing? It's 0.81 centimeter long. Well, nobody understands that. You know what I mean? So you just talk about the AR ratio and you leave the units off of it. Nobody even describes whether they're talking about inches or centimeters, and and it makes a difference because there's a unit there. So if you were calculating your AR in inches and another guy's calculating his AR in centimeters, then you're not talking apples to apples because you're left off the units. You're
right.
a Mars probe that hit the ground because the one guys were working in yards and the other guys were working in meters.
Yep. Okay. So,
but that being said, though, so what that really comes back to your question is like, hey, say the tile V-band housings and the T3 housings, an 82 AR and a tile V-band for like, say, a Zona Rotor 64 model, which is, kind of a small, like 600 horsepower size turbocharger. That is the same in the V-band housing as it is the T3, because it's essentially the same volute design, just with a different flange on it. But a lot of times what people don't realize when you go to T4, a lot of times the R part of the AR ratio changed because the turbo housing got into a larger frame size. So like when you go from, like, everybody's familiar with like T4 and T6 frame size turbine housings for the larger turbochargers, you can't directly compare those AR ratios because the R is so different in those cases. One is, overall 10 inches in diameter and one's overall 8 inches in diameter. So you can clearly see how, the area divided by the radius numbers were not going to be directly comparable between those two kinds of housings.
Got it.
But the T4 flange is it's not only a flange size, but it's also an opening size, is it not? Is that part of the ratio?
No, the actual the ratio is only calculated from the first cross-sectional area that opens to the turbine wheel. So everything of the housing that is above that or upstream of that first open cross-sectional area to the turbine wheel, everything that's upstream of that is not considered part of the volute and really has nothing to do with the way the turbo works.
Ah.
So whether there's a T3 flange up there or a T4 flange up there, it really doesn't matter. It's all getting crammed down into 10 square centimeters. And the T4 flange is way bigger than 10 square centimeters, and the T3 flange is bigger than 10 square centimeters, and the V-band flange is way bigger than 10 square centimeters. So really all three of those flanges, they don't present any difference in ultimate performance relative to the 10 centimeter cross-sectional area of the first volute.
Okay, but so if we were going to say a T4 housing, if the housing got overall physically larger in diameter, well then yes, then it changes that whole relationship.
But that wouldn't be because of the flange, though. So
right,
you can
exactly.
You can have T4 flanges flanges, like Garrett has a series of T4 flanged housings that is essentially the same housing as their T3 housing. It just has T4 flange on it.
Okay.
So those ARs are directly equivalent, and there's no difference in the power output limitations of either of those housings. It's based on the inlet flange.
Mm-hmm.
Okay, that makes sense. That's a good explanation too, actually.
A lot of times people ask me, like, well, I'm making 800 horsepower with my T3 header and everything, and I want to go bigger than that. I'm going to have to change to a T4. And I'm like, you really don't. You really don't, man. You use the same T3 header. We're just going to go with bigger flowing housings and bigger flowing wheels. The rectangle of the T3 flange is not part of your problem.
Mm-hmm.
And when they listen to me and we do it, they're always really happy.
So if you have a T3 sized V-band versus a T4 square flange, it really doesn't make any difference to you.
It really doesn't make any difference. No, that's not the thing that makes difference. But a lot of times when you have the T4 flange, you end up having some really large turbine wheels behind them that don't fit into the T3 housings. And this is where this kind of confusion comes from, because you'll see people running GT42 size turbine wheels with like 80 millimeter discharge diameters. Well, those will only fit into larger castings. And those larger castings don't ever go back and put T3 flanges on those larger castings. Those always end up being T4 flange or T6 flange.
Oh, so hold up here. So a T4 housing on a given turbocharger, if you had this one particular turbo, like let's say your customer that you were talking to, and they said, well, now I got to go to a T4 housing. Is it possible to get a T4 and a T3 that are exactly the same? And like so, you know what I'm saying? I'm trying to put this into words. I want to make, like he doesn't need a T4. He could do it with a T3, but how do you get?
You do it with the T3.
Right.
Well, you have to make housings. You have to make the housings. So for example, a T3 turbine housing, like in a 103 AR or 106 AR, you might have like a 68 millimeter turbine discharge in that. You're not going to actually run into the limitation of the turbo because of the flange. You're going to run into the limitation of the turbo because the turbine wheel is only a 68 millimeter outlet.
Right.
It's not the T3 flange part of it that got in your way. It's the blades that got in your way.
Mm-hmm.
And there's a lot more to it than that. I mean, because, all 68 millimeter or 70 millimeter turbine wheels are not created equally. Some have, 6 blades, some have 12 blades, some have long axial length. Long axial length, and some have short axial length. Some pose more restriction and offer more drive pressure. Some offer less restriction and less drive torque. So, there's a lot to it, but I'm just talking in generalities.
Yeah. I mean, that's a lot to this. I mean, Christ, that we're just talking about the exhaust side. Yep. Now you've got the compressor side, and then you got to put the motor in the middle of it.
All right. Well, let's stay on exhaust.
Definitely where the black magic comes from.
Yeah.
Because there's less ways to calculate and model that electronically than there is the compressor output. The compressor output is very direct to model and calculate with computers and predict what's going to happen. You have a lot of accuracy there. The dynamics of how the exhaust side works with the compressor side relative to what engine is on it, this is where the black magic part of turbocharger comes in, and this is where the calculators fall short.
Okay. I want to stay on the exhaust side for a second because somebody has a question that interests me. And it's a simple question, but a lot of guys have asked it. Divided housings. I mean, are they worth anything? Go ahead, fire.
Okay, well, with divided housings, yes, they're worth something, but they're not worth everything that they've been chalked up to be worth. The deal with divided housings is they really help 4-cylinder engines that have a need to spool a turbo and accelerate the turbine shaft below, say, 3,500 RPM. That's where their biggest benefit comes from. Okay, now that's great for Saab when they want a turbocharger that makes 300 horsepower and they want you to never feel the lag. Having the turbo shaft accelerate really easily below 3,000 RPM is just what grandma's looking for. She doesn't want to feel a turbocharger. She just wants the high efficiency engine with the good gas mileage, and she doesn't want to think about it any further than that. How does that play over onto race cars? Man, we could sit here and talk about that all day, but my basic perspective on this is that the gains to be made from the divided housings are really low in the engine speed range for 4 cylinders, 3,500, 4,000 RPM. All the pulses, there's so many pulses coming out of the engine, and by the time you get past 4,000 RPM, the alternating the pulses from volute to volute, the benefit of that really kind of goes away. And if you look at everybody that runs 4-cylinder cars today, very few of them are very interested in what happens below 4,000 RPM. You go to any of these drag race events, the shootout is coming up in Norwalk, Ohio. Nobody that is running down the track at the shootout is going to be below 4,000 RPM at any point in the pass. From the time that they load the car up at the light on the two-step to the time they go through the traps, the car was never anywhere near 4,000 or even 5,000 RPM. So the benefits of it for drag racing seem to be very minimal in my perspective.
Mm-hmm. Yeah, and that all makes perfect sense. We've had tons of people ask about that, but it seems like it's.
So am I getting this right that there's not really
response?
Go ahead. I'm sorry.
I said if you're looking for part throttle response in the 3,000 to 4,000 RPM range, there's some benefits to be had. They're not huge, but you can measure them, and they're real.
And do they have to be piped differently, or no? I mean, you're still merging in, but.
No, you need the header to be designed so that you're alternating the pulses from volute 1 to volute 2.
That's what I thought.
There has to be some thought put into the way it's designed. Yeah.
Okay.
Is there a downside overall?
Yeah.
Cost?
You need to run a 20% larger volute with a divided housing than you do with an open housing to make up for the frictional losses of the air passing through the divider wall.
Because you got
the housing.
Makes sense.
Double the wall.
More surface area inside there.
Yep.
A lot more surface area inside a divided housing. Well, that's all friction. Okay. Everybody used to like to extrude hone stuff back in the 90s. Well, that went away. Nobody does that anymore. That's just raw cast iron inside there for the most part, unless you're using a really fancy housing like a tile V-band. Those are very smooth on the inside, so you have less issue with that. But typically you need a 20% conversion factor to go from a divided housing to an open housing. So that is to say that if you had a divided housing that was a 100 AR and you wanted to go to an open housing and you wanted the performance to be the same, you would use an 80 AR open housing.
Wow. All right. That kind of kills the divided in my world.
It's heavier too. Yeah, I mean, I'm not really big. I'm not a big, pusher of the divided stuff. I realize it's popular. A lot of the header companies really like making divided headers because they're so artful. They're so beautiful.
Yep.
There's a lot of reasons to use it. Not all of them are performance based.
Yep. Got it. All right, Mike, you're up.
People, you had touched on, I guess angle of like how the turbine blade is acted upon by the exhaust, and you talked about number of blades. Can we have a little discussion about, I guess angle of attack, I guess might be the term. I don't know.
Like propeller pitch, so to speak. If you're like, talk about helicopter things, you can change the pitch on a helicopter blade, for example. You can't change the pitch on your turbine blades in your turbo. They're Inconel and they're cast the shape they are, and you get what you get. So you have to pick the shape you like to do the job you're going to do ahead of time because you can't change it. So, 12 blades typically accelerate the shaft better. Really, I'm making some huge generalizations here. And if anybody went to school and studied this stuff, they're probably just cringing listening to me. But I'm making some huge generalizations. The more blades, more turbine blades you have, the faster you can accelerate the shaft. Okay. But the trade-off of that is all those blades get in the way. They block the exit of the turbine. So you might have a 70 millimeter turbine discharge, but if you've got 12 blades, every one of those blades blocks some of that outlet. Okay. Now, if another guy's got a 70 millimeter turbine with a 9-blade turbine wheel in it, okay, and they're both 70 millimeter, the guy with the 9-blade turbine wheel is going to have higher choke flow through the turbine than the guy with the 12 blade, but he's not going to have the shaft acceleration advantage that the 12 blade guy has. So fewer blades, you get less blockage. The air goes through the housing easier, but you also put less power on the shaft typically.
Mm-hmm.
So a 12 blade would hypothetically create more back pressure faster also.
Correct. Yes, correct. But it would tip in a little faster. It would accelerate a little faster on the front end of things.
So like you said, there's a lot of shit to the exhaust side. I mean, a lot.
That's where the black magic's at. Yeah, I'm telling you. Yeah.
It sounds like a whole bunch of, you want your cake, but you want to eat it too.
Yeah, yeah.
Yeah, exactly. There's a whole lot of it. It's a balancing act. Everybody says, "Oh, I run, a 64, 66 or something like that," and they go, "Oh, a 66 millimeter, that's pretty big." Well, maybe it is, maybe it isn't. It depends on what the turbine wheel looks like.
Yeah, I've never even heard anybody ask how many blades on the turbine.
No,
no, everybody skips right past because nobody likes to talk about black magic.
I mean, I've heard people talk about the amount of blades on a compressor wheel. For noise and for flow and all kind of stuff, but I guess let's switch to that.
We've all been compressor fixated for generations. I mean, the T3, T4 hybrids of the late '90s. That was all like, hey, we want it to accelerate really quick, so we're going to keep a T3 turbine wheel, but we want a lot of flow, so we're going to use a big T4E compressor housing and wheel. Those worked really good. We thought they did anyway, and they did at the time, given all the other handicaps we had. But by today's standards, you would never run something like that.
Yeah, because I guess then the engine you're trying to Band-Aid is going to be your limiter.
Yeah, you're plugging up. To quote an old guy, Gene Berg, you can't get it in if you didn't get it out. So if you go small in the exhaust flow, then you can't get the air in because the other air didn't get out yet.
And I guess in all actuality, when the exhaust housing can't move the air past it, could it be looked at like you can't? I mean, compressors take power to turn. Obviously, like if you're trying to compress air, it doesn't just spin around. Like people look at a turbo and be like, "Oh yeah, just
horsepower in some cases." Yeah.
So
all through a little 8 millimeter shaft. Yeah.
Right. So that
I wonder why they break.
So that exhaust, flow or energy going through the housing, that's where the turbine side really comes into it. You need to generate the power required to drive the compressor at the level you want without, I guess, making excess. Correct?
Oh, in a sense, you're right. You want a little excess because you want to wastegate things and you want to control things. So you want the ability to drive it harder than you're going to drive it, but not by a whole lot, And turbine sizing, speed matching, hot side with compressor side is really where the experience and the wisdom aspect of this kind of kicks in.
Mm-hmm. Well, Tom brought up the ships. We were sitting here talking. He's like, somebody has to do this because like you see these ships with these turbochargers, like you could like put your head in. And
they're bigger. They're bigger. 8 feet in diameter. I mean, they don't guess at that shit, right?
I would hope not.
No, big ABB stuff. No, Brown Bavaria. Those are really big turbochargers. No, I mean that is really where all the engineering and technology that we tap in for race car stuff really comes. It never got developed for race car stuff. It got developed for big money stuff, which is shimming, wartime development. World War II was a huge period for turbocharger development. You can go back and learn so many interesting things about turbocharging from things that were developed during World War II to help airplane engines.
Mm-hmm. Yeah, that is. I forgot about that.
Replace altitude, to replace not having any air.
Yep, not having air.
So if you're going to go race at Pikes Peak, you might want to read about airplane turbochargers.
Yeah, that makes sense. That's actually cool. We were thinking about the ships because I couldn't imagine how much those big turbos cost. But
man, as much as on par with what the engines cost.
Yeah,
in some cases.
Yep. So we knew that there was math there. We also knew that it was out of our league, Mike and I.
Oh yeah,
but there's definitely
I need all the colors of the crayons for that one.
Yeah, but there's definitely definitive math there.
Don't eat the crayons, Tom.
No, I'll try not to.
So, I mean, this is another topic, and people are asking also about compounds, and we're going to get to all that, guys. We're depending on how long we can keep them chained on the phone here. When we talk about like the exhaust side overall, this is something people always talk about: back pressure, ideal back pressure, back pressure versus boost pressure. Is there any good rule of thumb or way to explain this to simplify what you're really looking to accomplish?
Well, it is. Really, the old 1-to-1 or 1.5-to-1 ratio of exhaust back pressure to boost pressure is really an easy, simple thing to keep in mind. And don't get bent if you're measuring and it's 1.6-to-1. Your exhaust pressure seems a little high. Probably you've got an exhaust system on the turbocharger. You need to consider You consider what the restriction on the outlet side of the turbo is contributing to that. So it may not be the turbo as much as it is you want to improve the exhaust system itself, so there's not pressure building up after the turbo in the exhaust system that makes your turbine inlet pressure appear falsely higher than you would expect. So, but generally speaking, street car, if you want some part throttle performance, you're going to live with maybe a 1 to 1.5 to 1 or 2 to 1 ratio of exhaust pressure to boost pressure, so that it's fun to drive and has some part throttle response to it. If you're building something that is just like a highway locomotive, it doesn't matter if it takes 5 seconds for it to really get going. You got analog and other electronic trip things to help you with that. Then no. Sometimes you want to build turbochargers where it's below 1 to 1, where it's might be 0.7 ratio of exhaust pressure to boost pressure. And you can do that. You just have to sacrifice other things.
Okay, so the back pressure, I mean, it kind of goes exactly what we would think, that if you're generating more back pressure, the engine is probably more responsive, better at
Correct.
bringing in boost sooner, but overall limiting factor. Okay.
And if the back pressure is too high, then you got the wrong turbo on it, or turbos.
If the back pressure is too high, then if the back pressure is too high, but the car is making the best lap times it's ever made, then tell the guy that's talking about the back pressure to shut up.
Okay. That makes sense.
Okay.
Yeah.
Because a lot of times people get fixated on this. Like, well, it was 48 pounds of back pressure, and I have 42 pounds of boost. So the 6 psi. I got to get rid of this. And you'll be like, well, how'd the car run? Well, we picked up 6 miles an hour, and we're 0.2 quicker. Like, so what's wrong with that?
Yeah.
But the back pressure side, like, were you racing back pressure? Or are you racing time slips? What are we racing here?
Okay. Got it.
Yeah, you don't fixate on it. It's just another.
It's there.
Yeah, I got it.
It used to be that nobody ever cared about back pressure, and then it's kind of the pendulum swung the other way, where everybody talks about back pressure, and people talk about there being too much back pressure when they don't even have a sensor measuring back pressure, but they're telling you they have too much back pressure. So
that's what That's an internet thing, I guess.
Yeah, the guy read that on Naziok.
Yeah,
exactly. I'll stay clear of the Naziok stuff.
They really got the short end of the stick here for whatever reason. It's whatever. Whenever we pick on internet dummies, it's Naziok.
They deserve it. If you've spent any time on there, Robert shouldn't talk about it, but he knows. He knows.
Yeah, well, I don't pick as many fights as I used to.
No, you can't on Naziok, that's for sure.
Arguing with people doesn't help anything. So.
No. All right. Well, we got a couple people wanting to know specifically about compound turbos. Do you have any experience with that? Turbos in series type thing.
I have. We worked with Shane Tackleberg on a really neat compound project earlier this summer.
Yeah, down at Scranton's.
Yes, and I broke their dyno a couple of times. Learned a lot of really neat stuff, and totally on the right track. A lot of the things that you do when you're compounding, it's a new thing for almost everybody you run into. Honestly, there's very few people outside of the tractor pulling industry that specialize in compounding. But really, when you get past running about 60 pounds of boost on a single stage turbocharger, you really ought to think about it, because that's really about all you can expect out of a turbocharger and get any kind of longevity out of it at the same time as, operated right around 60 pounds of boost. Sometimes people want to run 100 or 120 PSI boost. There's only so many ways to do that. You can have really expensive, titanium compressor housings and titanium bladed turbos, and, you can spend, tens of thousands of dollars on stuff like that, or you can just take some regular turbos and compound them.
Can you give us like the short version, kind of dumbed down of how the compound turbo system works?
Here's a really easy way to look at it. Okay, so you've got 3 turbos and they're all the same size. They're all exactly the same size. Okay, so you use 2 turbochargers to inhale ambient air and send that with a 20 psi bump to the second turbo, and so the second turbo inhales this really dense air that the first 2 turbos sent it. That takes it and adds another 20 psi to it and sends it to the motor.
Okay, and the second turbo in line isn't. Sorry.
All 3 of those turbos can be the same size in that analogy. typically what you see is 2 turbos used in compound, where you have a turbocharger that's generally speaking about twice as big as the second one, inhaling the raw air, compressing it, and sending it to a smaller turbocharger sends it to the motor.
And that's pretty much just because that the turbocharger doesn't know anything. It knows I'm taking in this and I'm spitting out this.
Doesn't care where it's going.
Right.
Correct.
So
the turbocharger doesn't know if it's on the top of the mountain or at the bottom of the ocean. Turbocharger doesn't know.
So the second turbo in line is getting not heated air, or not as heated air as it would have if it was coming from, something with a crazy exhaust side, a crazy hot exhaust side.
Well, the second turbo is inhaling the compressor output of the first 2 turbos, which is, if you split it up right and you share the work between the first stage and the second stage, no, it's not too hot air. You stay inside the sweet spot of the operating range for each turbocharger. The first 2 turbochargers each inhale 1,000 CFM, okay, and pass that dense air over to the second turbocharger, which is now able to inhale 2,000 CFM because it's being force fed by the first 2 turbochargers, and then raise that another 20 psi and send it into the engine with a minimal increase in charge air temperature, because each stage is not doing 60 psi worth of boost raise. Each stage does 30 psi boost raise or 20 psi of boost raise.
Is there a place for a specialty like compound turbo design that has less heat sensitive, I'm going to say hot side, but it's technically not as hot a side? Could you gain an advantage by using like a titanium exhaust wheel because you're not getting the direct exhaust gas? Something lighter. Has anybody thought of that? Am I a genius or an idiot?
I've never seen anybody try to employ something like that, but that might be a better application for the titanium aluminide turbine wheels that are temperature sensitive. You got a point there.
Yeah.
Mm-hmm. Wow, you got a point there.
I was going to go with option B, but hey, you got a point there.
I thought of that all on my own. All right, I'm done. Good night, everybody.
So on the exhaust routing of this, I've seen like through various things like Popular Hot Rod and Popular Mechanics even different methods of doing this. What is the most normal method of doing this? Like, how is the exhaust actually routed?
Well, you're right. There's different ways of doing this, and there's different ways of routing the wastegates. And, honestly, if you start getting into this, we'll just be talking about it forever. And
none of us have forever.
I don't know if really getting into a long thing about, how to build headers for compound turbos is a cool, a how-to thing. I guess it's an interesting topic, but there's a lot of ways to skin the cat. And,
yep. For another way, we'll leave that for another day. I mean, the people brought it up, and I remember years ago, not too many years, but several years ago, guys would try compound turbos in like in a Supra and say, there's no way it can work. It just can't work. It only works on diesels, and nobody ever knew why. But I guess
it's easier on diesels because diesels don't break as easy. And you get through the learning curve easier.
Okay.
More unscathed, but the learning curve on gasoline motors with compounds, it's very narrow, good spot, to get up into it. And even what Shane was doing, it all started out with really weak blow off wastegate springs so that things didn't run away. You have to realize that as one turbo set spool up and you want to try to spool all the turbos up evenly. You don't want one to spool up and then the other to spool up, though that's often what happens. It's not optimal. What you want is all of them to ease up together, and that's really the difficult thing to do with the piping. Transfer tube size, header size, how much wastegate you're going to use in each place. A lot of times the assumptions you make in the beginning are wrong, and everything you learned about this 4-cylinder engine doesn't apply to this 6-cylinder engine. It's really, it's a tough cat to skin in a lot of cases because you didn't kill it first.
And that's probably why because it sounds like there's no downside to it, but it's extremely complicated. So that's why people just give up on it.
It really challenges the most sophisticated people and the most sophisticated management systems. It really does.
Because that group Shane had down there was a pretty intense group of guys.
That's why I was bringing up the exhaust side, because I saw some stuff about how they were trying to manage what they were really trying to get, and it did look pretty crazy. I didn't realize it got that complex.
It's crazy.
But I remember this from years ago, even looking at it.
Take the idea and package it into a race car at some point, and it gets even.
Oh yeah, I didn't even think of that. Yeah, you're in a dyno room where you got pipes all over the place and nobody cares.
Yeah, I'm really looking forward to running some compound setups on my test stand just to evaluate, what our observations have been over the years, along with what we can see when we have more control over something that's not even connected to an engine, and just run the turbos without the engine and not have to worry about blowing things up. Just look at it from a more experimental perspective of just the turbo dynamics. Maybe we do that, and I'll come back and we'll do a whole real in-depth thing on it.
That'd be great.
It would be great because I think that as we progress here with
learning,
as things are getting better, like you said, we used to be in these hybrid things that were T04 or whatever, all this crazy stuff. This might be the next. I mean, and there are factory cars that are doing things like this to make them nicer to drive. So this is probably where we're going to end up.
Yep.
All right.
You will because if you do a good enough job with your sizing, you can get away with having a more rapid boost onset and shaft acceleration with your smaller, lighter turbocharger, and focus on that for response, and let your larger turbocharger just really come in on the top end and just really deliver all that CFM you're looking for.
Yeah, and you could have big engine torque with drivability and be fun. Mm-hmm. Okay.
But the control system is what's crazy in a situation like that. The control system is really what is your problem there.
Yeah. And, the diesel truck guys, they have actually the room thing is what hits with me. I remember looking at Chevy trucks. They have a ton of room underneath, so the piping wasn't an issue. And those guys, they just run two turbos, 1-into-1, but they make crazy power, crazy boost. It's neat.
Oh, yeah. Yeah. I mean, if you ever had a chance to go look at the tractor pulls, I mean, it's great content. You should go.
Those things are crazy. I just watched the blow up videos on YouTube where the whole engine comes out of the thing.
That's a crazy loop to get into.
Yeah, I know.
You don't eat the corn dogs if you watch it on the internet.
That's true.
I mean, you watch that stuff come apart and you'd be like, why would that guy ever get back in that thing?
I know.
When something that weighs like 10 times what he weighs just blew up in the air out in front of his tractor.
And the crankshaft is still spinning in the tractor. I know. It's crazy. I love that.
Well, and you have to wonder about the people sitting, along the mid area of the track. Too.
Yeah.
How wise is that in some cases?
That's what see, living in New Jersey, that's the shit you think about. I think about that. It's like, wow, there's no kind of catch fence that would catch that block, is there?
Well, they could never have a tractor pull here. You kidding me?
Yeah.
State police would kibosh that in a minute.
Send them a YouTube video. It'll never happen here again. All right. I'm trying to think what other ones I got. Oh, this is always one that we've gone back and forth with, and we had a little bit of discussion about it here and there.
I was probably right, though.
What?
About whatever you're going to ask.
Wastegates.
Oh, okay.
Yeah.
Any general guideline? I mean, everybody says, what is it? Big boost, small gates.
Yeah, small gates.
Small boost, big gates.
Yep.
Is it?
Well, that's really the rule of thumb, And I think with wastegates, a lot of times people think, you don't really need to worry about it. I'll buy the most affordable thing I can get my hands on. But your wastegate is really doing a very, very important job. Okay. And when you park your car in the trailer, the wastegate's in the closed position, right?
Mm-hmm.
Okay. So you just, it was sitting in the pits. It cooled down. You fired it up. You ran it for about 30 seconds or so to put it in the trailer. Nothing got to temperature. None of the moisture that was in the exhaust had a chance to evaporate off or anything. The fuel residue, race gas, E85 and whatnot, is a lot of acids in that. Okay. So just the act of pulling the race car into the trailer puts a lot of acidic moisture into the exhaust system. That's where your wastegate's living. So if you don't have a high quality wastegate made out of high quality non-corrosive metals, then that can all seize together. And you go to the track, 3 weeks later. What if the gate doesn't open?
Mm-hmm.
What's the failure mode there? Well, the failure mode when the gate doesn't open is overboost.
Is oops,
which is it's head gaskets, head studs, broken pistons. So I think a lot of people underestimate how important the job of wastegate is, and don't put enough thought into picking a really high quality one. And of course, I really recommend the tile wastegates for that reason.
Okay, great. We actually have somebody who's on hold that might want to ask a question. You want to do a live question or no?
Yeah, sure. Yeah, go ahead.
Hello, caller. You have a question?
Actually,
Identify yourself.
Guys, this is Rye from Bolson Speed. I'm also on the other podcast. I'm going to catch you guys at the end of the show. I don't want to interrupt. This is really good listening. So I'm going to put me back on hold.
Okay.
You can listen online.
No, I know, but I wanted to talk to you guys. I had a proposition for you.
Oh, okay. All right. So you want to talk after
the show?
Or do you want to talk after we're finished? Or do you not want to talk on the air? Is that what I'm getting at?
No. I want to talk on the air.
Okay.
Talk on the air.
All right. Hang tight.
No, just hang out. Go
All
ahead.
right.
Yep.
Back on hold with you. Away with you.
What other podcast?
I guess probably Scott's.
Maybe they want to fight.
No, I don't care. How about they buy this one? We'll sell them the audience. Cheap. All right. Well, that was kind of useless. I was all excited we had a call. And it was just, maybe he's a spy. All right. All right. Let's see. Other questions. Wastegate, we went over. I got pretty much at least what we would consider like as technical as we could understand views of all this. You got anything else, Tom?
Yeah. Well, I want to ask about, this could be real quick. Oilless turbos. What's up with them?
Yeah.
Are they silly? Are they cool?
I think there's some value there, it's offset by some hassle, but I think there's some value there. I just don't think, and it hasn't been my experience, with the Aerodynes in the 90s that you saw for Harley Davidson kits. Those are the first oilless ones I ever saw. They have a really frequent service interval, and I find that most people like to run a turbocharger for maybe 2 years or so without really worrying about it. After 2 or 3 years, if they start to have some problems with it, they can kind of accept that and go, well, yeah, I've been beaten on this for a while. Maybe I'm starting to see some problems. I need some service for it. That seems to make some sense. But the idea of, every season, basically spending half the money that you would spend to buy the turbo in the first place to service it. And I don't know if that's still the case anymore. I don't think Aerodyn's even in business, but the Harley kits, you spend so little time driving a Harley for the most part, especially if you put a turbo kit on it, that you probably don't run into that very often.
Yeah, that's kind of what we thought, that how much time does a motorcycle really get put on it? I mean, it doesn't get driven like a car.
Motorcycle and buy another one before it even needs service. So it probably was never an issue there. Comp Turbo is a legit company that makes products. I know they have an oilless product. I don't have a whole lot of experience with it, but I don't see how, and maybe have them on to talk about it, but I don't see how you get very far down the road for very long without having to service it. I don't know what you're going to put in there for a lubricant that's going to do the job long enough to make people happy. So,
all right,
man, we've got everything answered. That's awesome.
I think what I know that I didn't know before is I have a little better handle on the exhaust housing side and what that all means, and that actually helps me out a little bit. But what I do know is there's certainly it's required to talk to somebody like Robert that knows what he's doing to try to get yourself at least started here. You can't. I think it would be pretty tough without practical experience doing this to pick out the right turbo. I don't think you just do that. It
can be a real challenge, especially if you're new to the hobby, you're new to the sport, and you're trying to get your bearings, but there's a lot of people that we distribute products through that are very helpful in selection. There's a handful of companies that do a real good job of product selection and support with that. You got Real Street, Import Image, IAG, Rally Sport Direct, Stream PSI. These are all guys that know a lot about turbos, know a lot about what's been going on in this particular vehicle, in this particular year model, what options are available, and can help you point in the right direction. So you don't always have to go, straight to the top of the TP to get the answers. A lot of times, some of these other reps can be very, very helpful when it comes to selection.
Okay.
All right. Well, why don't you, plug?
Yeah, plug away.
Whatever you want to plug, and we're going to hold you to the compound turbo deal. Or at least to get you back on here.
Let's do it. I'll tell you what I'll do. I'll make some videos of it so that we can even link the videos in your thing. People can watch the videos and have some questions about the videos even.
Somebody texted me a second ago. I got my phone sitting here. It's not on the counter because when it is like, you always hear something. What exactly does a turbo test rig look like?
Well, you have to have an air factory, so you need really big air compressors.
Okay.
Then you direct that air into a propane combustor, and then through the propane combustor, you direct the air into the turbine housing of the turbocharger, and that generates your shaft speed. You instrument the turbocharger with shaft speed instrumentation and SAE compliant volume and pressure and temperature measuring instrumentation, and you operate the turbo throughout the entire compressor map.
Okay.
And collect all your data.
So
sounds cool.
I guess what he was asking is like, how do you drive the turbo without a motor connected? But I think I've seen those things on not
I use a propane combustor.
Yeah. It's not on YouTube for testing turbos. Guys are making like ramjets or something. They called out these things.
Yeah.
There's all kinds of crazy shit.
That is essentially operating what you call like a single loop mode, where the compressor output is what you use to drive the turbine, and you cannot compressor map that way. You can just get one line right up through the middle of the compressor map with that. So
Gotcha.
you can't really evaluate compressor characteristics that way or do any kind of mapping that way. You have to have an independent air source, and you either have a series of really large electric compressors or you have some really large diesel powered air compressors for that.
Gotcha. But it's that principle. You're generating essentially fake exhaust. Well, it's real exhaust, but it's just not exhaust from a motor.
Yeah, it's not exhaust from an engine. It's exhaust. It's compressed air from an air compressor that you run through a propane combustor, and that output is used to drive the turbine. There's a lot of valving involved in that. There's a lot of solenoids and valves involved in that. A lot of computer controls involved in that.
It must sound cool.
It's fun stuff.
Yeah.
Does it sound cool?
Helicopter, man. Yeah, It sounds like a helicopter inside your building.
It's like the blower dynos at the top fuel teams. It's just crazy to sound. You never hear it when it's on the car.
Hey, are you guys going to be going to the PRI show?
Yes. Yeah. Every year. Yeah.
That's again.
Oh, cool. Well, we'll have to meet up because for the first year, Zona Rotor is going to have a booth at the PRI show.
Oh, sweet. Yeah, definitely got to do that.
Yeah,
no doubt.
Definitely come by and visit some.
All right. Well, listen, plug your stuff and phone numbers, whatever.
Forceperformance.net, 972-984-1800 is our phone line. You can get support and ordering information, ask questions that way. Sales at forceperformance.net is our general email inbox. If you want to email me questions that you just want to go, hey, man, I think I got a question Robert would like to answer, ryoung at forceperformance.net. You shoot me an email. I'm not the quickest responder, but if you got an interesting question, I'll probably get back with you in a reasonable amount of time. Zonarotor.com is our hot new product line. It's a joint venture between Force Performance and Tile Sport, where we're putting all of our new development products into one brand and one product line, the Zona Rotor Turbocharger line. So go to zonarotor.com and check out the turbochargers there. And if you go to the PRI show, be sure and come by the Zona Rotor booth. Zona Rotor, Tile Sport, Force Performance.
Fantastic.
Awesome. Hey, we'll try to have you on like right before the show if you want.
Yeah.
Oh, that'd be great. Yeah, that'd be great. Maybe I'll have done some compound stuff by then.
Yeah.
All right. Well,
test stand.
Thank you very much, because a lot of this stuff, it cleared up, a lot of the questions I had. A lot.
Very cool.
Well, it's my pleasure. I always like hanging out with you guys. You're fun to talk to.
Cool, man. Hey, I'll be in touch, Robert.
All right. Thanks a lot, you guys. Take it easy.
Thank you, Robert. See you,
man.
Yeah, bye-bye.
I know we're going to say the same thing. Good dude, smart guy.
Yeah.
But we just keep it's really neat. He cleared up a lot of shit. You look like that nobody home look in your face.
No, like you talk to these guys and there's so many. I mean, I guess I'm not happy realizing how stupid I am. I guess what it comes down to, there's so much to this stuff. And what really bothers me is that what I was just reflecting on is how often I've tried to learn stuff on the internet and been giving completely fucking wrong information.
Oh, wow. That's never happened to
I
me.
know, but it's like, it's
called the Naziak effect. Fucking idiot. When did you wake up?
I know, but it's like, I can think of like 3 very specific things I read about, turbine AR ratios or turbine ARs and why and how that I would say are now I understand why these were people talking under. And they were articles, dude. What, is somebody fucking tolling on me?
Guido.
Yeah, that's fine. I can't fuck with him.
Hey, Rye from Bull City, just hang in there 1 second until we get done blubbering like we are, and we're gonna bring you on. Just give it a minute. Don't hang up.
Huh?
The guy.
Okay, yeah, we're gonna get him.
Yeah, because we're still.
You want to get him now?
I don't care. Yeah.
All right. So what's up?
Hey, what's up, guys?
You better not be trolling.
No, man, I'm not trolling. So I want to say I am a huge fan of your guys' show.
Mm-hmm.
I actually got into automotive podcasts because of your guys' show. And I've actually talked to you on Facebook a while ago. I found you guys when I was deployed overseas and listened to pretty much, man, I don't even know, started from like episode 1 all the way up to pretty much current.
Oh, so you're military. So we like you already.
Yeah, I remember this guy.
Okay.
Yeah, then thanks again, man. Thanks for your service, really.
Yep.
More balls than I got.
Talked about back in the day. We talked about when that 5th gen Camaro went end over end at the half-mile event. We chatted on Facebook a little bit.
Yep.
But yeah, so I am on the other guy's podcast. I'm not trying to plug anything or like that, but I threw down the gauntlet over there. You know, I don't know what the status is of your guys' drag week car, but I have a little drag week car, and we're going to be in the same class together. So I figured, you know, maybe we can make it interesting. Have a little gentleman's wager.
Well, if
you would win this year.
Yeah, you would win this year because I unfortunately left a lot of stuff up to other people rather than myself.
Right.
Partially because you couldn't do a lot of it.
Well, I can't do a lot of it. I mean, yeah, I did buy some of the stuff to do the things I wanted to do. You know, I want to learn a ton of stuff, you know, but I have no time. I mean, I'm busy.
Yeah.
I wish I had the time to do everything I want, but I just don't. So my status is, now are you the guy that said that you had got a Huron kit?
No. I have a 1994 Ford Mustang with a really original engine combination. It's actually a Turbo LS. Not a lot of guys do that.
Wow. You really stepped out.
Yeah, so
good for you.
You know, we could just settle. I was hoping, you know, it's unfortunate. I understand though, man. If you're busy and you got stuff going on, and it's not lost on me. It's taken me 3-4 years to get this car to where I finally felt comfortable to sign up for Drag Week. So I can sympathize with you there, but. Yeah, I wanted to, you know.
Yeah, I just end up donating every year. That's all it comes down.
Well, we're going to go. I mean, we're going to go for at least a day or two. You know what? Refresh my memory. What racetracks are? It's Gainesville? It starts at Gainesville, right?
We're starting at Atlanta Motor Speedway, day 1. Day 2 is Darlington, South Carolina. Day 3 is ZMAX in Charlotte. And then from there, you go to Bristol, Tennessee. And then from Bristol, we finish in Atlanta.
Oh, I thought it was Gainesville.
I didn't think it went there.
Yeah.
Okay.
And North Carolina.
Are you talking about Atlanta Motor Speedway or Commerce?
Commerce.
Yeah, okay. Yeah, Atlanta Motor Speedway doesn't have a drag strip.
Yeah.
They got a 2-mile oval.
I'd win that one.
Which would be cool.
Yeah, you'd get me there.
I think I'd be all right on that one.
Turns.
So, I mean, we'll get with you somewhere out there because we're going to go. We're going to try to go to a couple of them.
I'll be. I got the. It's a burnt orange, copper, or whatever color you want to call it. 94 Mustang GT, big old 5-inch exhaust, either coming out of the hood or out of the fender. I haven't decided where I'm going to reload.
Oh, so subtle car. That's
Yeah, very subtle, low key.
Yeah, I want. I really do want a street car. I'm going to borrow a phrase from someone else who I won't name, or you'll get irritated, Tom. I want to like the car as a car. You know, I want. Yeah, I don't want it to be just a race car. I don't.
Yep. Well, anyway.
Mine's 5-inch exhaust out of the fender, and it sounds like Monster Jam everywhere you go. So,
Well, that's all right. That's cool, too.
Look, I'm more than willing to keep anything interesting at any point in time. I don't mind that, but it's just kind of senseless talking about it. I mean, people always ask about the update, and I think I talked about it. I think I talked about it when I just came on to tell people we weren't here.
Oh, we talked about it like 2 months ago that we were having trouble getting the turbo kit done. And nobody knew why. All of a sudden, everything was a big problem.
Mm-hmm.
So it
was the same car it ever was when it was initially talked about.
Exactly. And so you bought a turbo kit.
I believe there's audio evidence of that,
I'm
too.
sure you're damn right there is. And then you sent a turbo kit down there, and
I bought a turbo kit. I sent it down there. I bought the stuff from Huron. They took good care of me. They worked with me to try to get it as close to what I needed to try to use the things that I already have, which was very nice of them. And I mean, can't say enough good things about him. And to me, if I was looking to just bolt on a kit, in the very beginning, when they released their kit, I had talked about it. I said, man, I can buy that and I can be done. Everybody was like, no, don't do that.
Well, yeah, the one important person said that.
I hear you. Yeah. So now the kit is down there. But I mean, look, I'm just being realistic. There's just not any way it's going to possibly get done. I mean, I knew it in June when all of a sudden the kit was a problem again.
Yep.
So that's where it stands.
Mike did try. Right? I mean, we busted ass, trying to get shit done.
Look, I even bought a dyno just to fuck around.
Yep.
I mean, I did.
True story.
True story. I bought a dyno from Allison. I bought a hub dyno from Allison because I want to be in a little. My problem is I'm a little bit of a control freak, as you can see by the studio.
Did you say a little bit?
A little bit.
Dick.
I like to have things in my control. Everything that I do for work, business wise, all the hosting is done here.
He's got a Sonic drive-through in his yard.
I'm working on it. Wow. But that's so. I mean, for me, I would much rather be the person to say Rich Guido is that he did everything himself.
Yeah,
and he's clearly got more time than I do. I just don't have it.
Yeah, same.
So that's where I'm at. So what do you want to do? You want to race heads up, or what do you want to do, or you just want to bracket?
Well, my idea. The idea was, I don't know. We can make a 2 out of 3 deal. I couldn't think of anything in the third one, but best highest finish in class for the week, and then on the end of the day on Friday, after we're satisfied with running 850s all week, you turn them up and let them eat, and we go head to head.
I don't know if they're going to do that again.
Well, you could do it somewhere.
Yeah, we're good.
Yeah, and I don't know if they're going to do that again. But I mean, yeah. Look, I know. Like this goes back to the conversation with Belle Divine when we were talking.
Wait, time out. Where are you from?
North Carolina.
Okay.
Well, we have a mutual friend, Richard Homer.
Shut up.
Yeah.
Okay. I know Rich.
I used to work for him like 10 years ago.
Really?
Yeah. Me and Rich go way back. We live in the same town.
Okay. Jacksonville. Does he live in Jacksonville, or that's just where to shop?
Yeah. I'm just north of Jacksonville.
Okay.
But I lived in Jacksonville up until 2008. And then
what branch were you?
A little bit. Marine Corps. Still in.
Oh, yeah, that's right. It's everybody there is a Marine, except Rich.
Yeah, pretty much. Yeah.
Okay. Got it.
But yeah, me and Richard have some business to settle when he gets that S550 Mustang up and going.
That thing's close. I mean, they've done some stuff with it.
Oh, yeah. That's going to be a bad ride. I can't wait.
Well, listen, how far are you from ZMAX?
I'm about 4 hours. We were out there for a streetcar takeover earlier last month. And that's when my balls dropped. I got confident. I actually ran my first 8-second pass. And then immediately after that, I was like, you know what? I'm going after the power and speed guys.
Okay. Cool.
So he went from a fan to being cocky. I see how it is.
Well, he's done a burnout.
Okay.
I mean, it's hard to argue with him.
Now, this is true.
Yeah, we hear a lot of people talking online and speculating what's going on. And I know you guys are huge Facebook guys, like you say all the time on here. And I didn't want to hear speculation from other people,
No, and like I said, I can't clear this up any more than I have. I can tell you this, that my number one goal and priority in life, it's all I live for is work, is making money, because I came from having to really work and not seeing a lot from it. And then all of a sudden, as my life changed, I've done better than I ever thought I could ever possibly do. And it makes me just keep thinking that you're not at the end yet. And if there's things that I can do that require my attention, like even sometimes like people say, well, why don't you devote more time to the podcast? Because we did this kind of more for fun than anything else.
Yeah,
this wasn't
started out political.
Yeah. It
make
did
fun of people.
It did start out as political to kind of, tool on people. And then, it turned into this. It turned into a car podcast. So for me, the most important thing is everything that I do
daily. Me too.
Daily.
It's got to be.
It's got to be about work, and because I like having to have money that I could call up Allison and say, okay, look, I've thought about it. I want a dyno, send it to me. Get it done. What do I got to do? And you don't think about it. It's like that security only comes from when you really work, or you find your thing that you can make happen. And right now it's good. Might not always be good, but I want to make sure that me being good right now takes care of me being good in the future.
All right. Well, listen, you shouldn't have to explain that anyway. Our
I
life is what our life is.
I know, but I mean, like these people, I think there's a lot of people that the car stuff is all they do. That's not me.
I know.
It's you because it's what your work is.
Well, yeah. But this part of it isn't what we do.
No.
It would be cool if it was, and we're not downing anybody that it is their life.
And I made it abundantly clear. I don't want to get back into doing this.
All right, quit defending yourself.
I don't want to dyno. I for customers, it's not any of the stuff I want to do. I mean, this is for enjoyment. That's all it is. And
yeah, I'm not knocking the hustle there. I wish I could grind on hard enough to get me. Well, I not wish. I know I can eventually, but
you just got to find it, man.
To grind hard enough to buy a dyno. I got a few more years left in the gun club here, and then moving on to bigger and better things. But
yeah,
dude, nobody's hating on your hustle, man. I don't think anybody's.
No, but I feel bad because
we get it.
No, I feel bad because
built overnight.
We talked about all these people, and then about meeting all these people and everything. And look, for me to go to PRI and to go to Drag Week just to go for a day or two, I hate that. I mean, I'm not a spectator. I've said that before, that if I'm not actively involved,
same way.
Yeah, I don't want to go. Like everybody's like, hey, you want to go to track and watch a race? No.
All right, you still sound like you're defending himself. The guy wasn't attacking you.
I am defending myself.
Well, don't. You don't have to. He wasn't attacking you.
I hope not. He's probably a much better shot than I am.
I'm sure he is. And that fucking Kimber, you'd have to throw it at him.
Oh, Christ.
We got the world's worst Kimber up here, by the way.
You guys up, man. I wasn't calling to beat you guys up.
No. And I'm not worried about it either. And look, I have no ill will towards the other podcast. And, it's Scott's podcast. I don't care. Real Tuners. I'll say it. I don't give a shit. It doesn't matter to me. I don't dislike the John Booley guy, if that's how you say his name. I think these people specifically think I spend more time thinking about him than I do. That's all I can tell you. So no, don't sweat it. It was never taken that way, and I appreciate you listening to ours. I mean, hell,
yeah, man, for sure.
It's nice, that you can use that one and talk, and then come here and listen for entertainment and accurate information.
Hey, maybe we'll try some match race when we finally get the car running, because it's going to happen.
Yeah, we can figure out finally which one's faster, square ports or cathedral ports.
Well, I mean, jury's not out on that anymore, but whatever.
Yeah, I think that was answered pretty definitively a couple times.
We could settle that one.
Yeah.
What does your thing weigh?
Yeah.
Like 2,300 pounds?
No, I don't know, dude. It's easily, with me in it, I'm 250 pounds. It's every bit of 3,200 at least, for sure. But it's a real basic. It's a 6-liter. It's got a billet 84 millimeter Borg Warner turbo on it. Turbo 400, running on a Megasquirt Gold box.
Mm-hmm.
It's E85 car. And it's got flex fuel capability, so I can put pump gas in it, drive it anywhere I want to. 28-10.5 slick, and it's been so far the best we've gotten out of it is an 871 at 156 miles an hour, and that was actually on a radial, and that was my first time on a radial at Streetcar Takeover. So, looking at the data, I hate saying that phrase. There's way more left in it, but
yeah,
there's some room for improvement there that we found. And
is it your first time going like that fast, like ever?
That was, yeah. I actually, when the car had a Ford motor in it about 8 years ago, the fastest it went was a 1080 with a stick and a 100 shot. And that was like a 331 stroker. And then
that's actually a crazier ride, though.
Yeah,
with a stick and an nitrous. Yeah,
it was. And I think the car was more fun back then. And now it's, like I said, the exhaust is just punishing how loud it is. I wish I would have done something different there. When I was young and I was a kid, and you guys talk about it, you crack on Tad for it all the time. Like, you take the power steering off, you take the AC off just to try and, it frees it up. It's just a waste of space and power. Like, now that I'm older, like, shit, man.
Yeah. Now that we've grown up.
Yeah. Where's that where can I put that AC compressor?
Yeah, I was like, that car is cool because it has AC.
Yeah,
exactly.
So I am a little jealous that you'll have all the streetcar amenities. I do wish I could go back in time, but I've had this car for going on 18 years now, and I'll burn it to the ground before I ever sell it. So I'm married to the piece of shit.
That's honestly kind of why I have that 2001 Corvette, because it's like I seem to collect things. They never leave. I don't ever seem to sell them. I sold that black one because the motor was hurt and I didn't want to fuck with it. But other than that, I just hold on to them. But that's, and look, we'll do something. I think it'd be fun. It'd be great.
Hell yeah. Even if it's not a drag week, I got some buddies up at Jersey there that they do quite a lot of racing up there. What's the track that's still up there? Atco?
Atco, yeah. And Atco's a good track. It's usually well prepped. Englishtown's gone, yeah.
Hey, well, jury's still out on Englishtown. There might be some story there, but
yeah.
Listen, man. Next time are you stateside all the time now, or are you waiting?
Yep.
Oh, so you're done.
I ain't going nowhere.
All right. Well, next time I get down to Homer's neck of the woods, which is actually going to be sooner than later because I haven't been there in a while, I'm going to have him get a hold of you, and maybe the three of us will go to lunch.
Yeah, hell yeah.
Or something.
I'll talk to Rich tomorrow and let him know.
Yeah, tell him I said hello. I haven't talked to him in a while.
Cool, we'll do. Keep everybody posted. Let us know which tracks you're going to go to for drag week. It'd probably be the good one would be to go to ZMAX. They're going to be running. I think they're going to be doing the 4 wide shit there.
Well, I just talked Tom. I mean, for us, it's not. Well, I guess realistically, where it was before, is it any further or closer than it was before?
No, it's easy.
Yeah,
I think it's
and ZMAX is the best place to go. I mean, hotels, restaurants. There's a ton of shit around there. There will be nothing going on, so everything will be empty.
Yeah, you can get an Airbnb and stay at Charlotte Motor Speedway in the fucking
and the suites
racetrack.
Yeah,
really
crazy.
I've actually been in Joey Logano's suite.
Really?
Yeah, it's wild. It's wild. Yeah.
Okay.
We heard about that at Streetcar Takeover. I was so pissed I stayed at a regular hotel.
Yeah, I guess this is probably a little more developed area than where.
Yeah.
Where, not knocking the non-developed area out there. I'd love to live out there. Cornfields and nobody around bothering you. Oh, it's perfect.
No, Charlotte's good.
Right.
That is probably. But we'll keep everybody posted.
Yeah, absolutely.
It'll be on the show.
No, wait. Look, I said it before. I'm going to go there. I'd like to get my little truck finished, and I'd like to drive it there. To be honest with you, I may run in the bracket class if I can.
I got a little turbo truck I'm working on too, so we can do that too.
That we could fuck with.
yeah. Let's go.
All right, buddy.
All right, man. We'll talk. Thanks for calling, dude.
All right, guys.
See ya.
Yep. Have a good one.
Bye-bye. I remember that guy. How the fuck did he end up on Scott's podcast?
I don't know. Maybe we'll snipe him.
Yeah.
Get him over.
That was Tom. Guy's 250, dude. 250 Marine.
Yeah, I know.
Gun skills, everything.
That's right. I got gun skills.
Mm-hmm.
No, I don't. Not like him.
I'm
an old guy. It's a no lose for me.
Oh, so wait a minute. If you got to the point now that you're going to say, well, I'm an old guy, you're going to beat up an old man?
Yeah, that's right. That's right.
Dude, that is like 1 foot in the ground when you're saying you're an old guy.
I would never.
Oh, my God.
I would never do that. He's a Marine. He wins anyway.
Rich Guido will protect you.
That's, I don't know how much that would cost, but I could try that route.
All right.
Anyway, hey, good show. That was good. It was
good.
All right. Cue the music. I'm hungry.
Yeah. Nothing else? That's it? That was kind of loud.
Steaks.
Steaks, yes. Sous vide steaks, or are you making?
Nah, I think my wife's going to cook one while I'm on the way home.
All right.
Just grill.
All right. So your next week is okay or not okay?
Next week, I don't think is okay. We'll talk.
All right. We'll get it figured out.
Yep.
But we'll see you guys at some point.
Yep.
See ya.